Hi, welcome to Tammy the Tutor. We are on section CC1, lesson 1.2.1. Okay, the first question is 1-46. It says match each of the following descriptions of pennies with its possible numerical expression, then calculate the value of each expression. Okay, so they have four different number equations, but then they have A through D, which are in words, and they want you to match which scenario goes with the equation. So I think it would be easier if we start reading A, B, C, and D with the words and match it to the number sentence. So A says 11 piles of 10 pennies with 7 leftover pennies. So even if the words, the way they've written it, maybe wouldn't seem that familiar to you, it's a dead giveaway because the three numbers in A are 11, 10, and 7, and you can clearly see that number 3 is using 11, 10, and 7. So now that you know which one goes with which, I want you to see if you can understand why they've written it this way and what that means. They're saying they have 11 piles of 10 pennies with 7 leftover pennies. So they're saying, I have 11 piles. Like, can you picture piling up 11 pennies? Sorry, there's 11 piles with 10 pennies in each. So let's just say you literally piled them high, but you have 11 of those piles, and then maybe in the last pile you only had 7, you didn't have enough to do 10. So they're saying it makes so much sense to just go ahead and say 11 times 10 and then add the 7 left over in the end. Okay, so number 3 matches A. And then, we also need to solve for the expression. So 11 times 10 is 110, right? Because 10 times anything is just that number and then add a 0. But then we have to add the 7 leftover pennies. Okay, so the answer to this one is 117. B says a rectangular array of pennies that is 9 pennies long and 12 pennies wide with 5 leftover pennies. So we have a 9, a 12, and a 5, and it's super easy to see that that matches number 4. Okay. You might be wondering what they mean by a rectangular array of pennies. Okay, so an array, especially it says a rectangular array, it's going to look like a rectangle, and it has 9 pennies long. So we could say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 12 pennies wide, and that's talking about the width. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so if we went ahead and did this all the way down every time, it would, look something like this if I were really going to do it perfectly. But you can see that that does make a rectangular array. And then somewhere over here there needs to be like those 5 leftover pennies that there weren't enough to make an entire row. So do what it says, the 9 times the 12. So that's 9 times 12, which would give us 108 plus 5 left over is 113. Okay, so we still need to solve that one. 8 times 12 is 96. And then we need to add that leftover 7, and that would be 103. Okay, D, a rectangular array of pennies that is 6 pennies wide, 20 pennies long with 5 left over. So 6, 20, and 5, and there it is. And we knew that anyway because it was the only one left. So 6 times 20 is 120 plus 5, and that's just 125. Okay, let's move on to the next one. Okay, write one whole number or fraction in each blank to make each statement true. 100 pennies equals how many dollars? Well, that's easy. 100 pennies is definitely $1, and they said use a whole number or a fraction, so there's our whole number. 200 pennies equals Well, if 100 pennies is $1, then 200 pennies is $2. 50 pennies equals, okay, so that's not enough to be one whole, so they said do a fraction. So you could say 50 1/100ths. You could have said 1/2, because 50 pennies is 1/2 of a dollar. 10 pennies equals 10/100ths of a dollar. Or you could have said 1/10 of a dollar. That's also true. Okay, 1 penny equals 1/100th of a dollar. So not too difficult. Just write it what it really is. Okay, 1-48. Matthew's mother asked him to go to the store for her. To get to the store, he walked 7 city blocks. He caught the bus and rode 13 blocks. He got off and walked 1.5 blocks to the store. He purchased the items his mother wanted and returned home the same way. How many total blocks did he travel? Okay, well, let's figure out how much he went one way, and then we'll just multiply it times 2 because he had to go the same amount back home. So the first thing he did is he walked 7 city blocks, caught the bus and rode for 13 blocks, got off, and he walked 1.5 more blocks. So 7 and 13 is 20. 20 and 1/2 is 20 and 1/2 total. So if we double the 1/2, we get 1. If we double 21, we get 42. So add those together and we've got 43. He went 43 blocks total. Okay, 49. Which numbers make these division problems correct? Replace each box and triangle with a single digit number. Okay, so the first one, we have a number missing in our dividend right there. It's 6 is being divided into some bigger number, and when you divide it, the answer is 12. Well, the reasonable thing to do is just multiply 12 times 6, and whatever that is should be that number right there. Well, 6 times 12 is 72, so the number missing in the box is 7. If you come over here, 4 is being divided into some big number that we are not quite sure yet what it is, and the answer is also 50 something, and we're not sure what that is yet. So if you really think about it, I think we can get the 4 and the 8, their relationship, to find this number. See how 8 is the last number in that division problem? Well, think about it. 4 times something would give me that 8. Wouldn't that be 2? So the same thing is 4 has to divide into some number here to get me 5. So 5 times 4 is 20. We already have the 2, so the number missing in the square must be 0. So if we wrote it like this, maybe it would be easier for you to visualize it. See, 4 divides into 20 5 times. 4 divides into 8 2 times. Okay? A line segment is a piece of a straight line. On your paper, draw 2 line segments that are the same length and each about as long as a pen. Draw marks on the first line segment to show how you can divide it into 8 equal parts, and B, draw marks on the second line segment to show how you can divide it into 5 equal lengths, and C, was one of these tasks easier than the other? Which one and why? Okay, so let's do, they didn't say a line. Ooh, if I did arrows, that would mean a line. A line segment has 2 dots on the end, and they want us to make another one that's exactly the same length. Okay, this is probably not exact, but it's pretty close. So the first one, they want us to try to divide it into 8 equal parts, and obviously this is not going to be perfect, but you can get pretty close. So I'm going to divide that in half, and then this section I'll divide in half, and this section I'll divide in half. And as you can see, it's pretty close to 1, 2, 3, 4 equal parts, but I need 8. So let's take each section and divide it in half one more time. And then we have 1, 2, 3, 4, 5, 6, 7, 8. Okay. The next one we want to divide into 5 equal parts. Let's see, maybe 1, 2, 3, 4, and 5. Seriously, not perfect, but not bad. That's 1, 2, 3, 4, 5. And see, it says, was one of the tasks easier than the other? Which one and why? Yeah, definitely. It was so much easier to divide 8 into equal parts than it was 5. And it's simply because 8 is an even number. And when you're doing even numbers, you can always go half, 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 half. And even though it's not perfect without a ruler, you can get really close. But on the odd numbers, it's a lot harder. You just kind of have to eyeball it at first and then try to make the rest of them look like the first one. And if you mess up terribly, erase it and do it again. You'll get the hang of it. Okay, that wraps up this section. I'll see you next time.